As propulsion machinery for ships, a steam turbine not only produces a large stable output, but also includes various technical features that maximize the plant's thermal efficiency. It's essential that every marine engineer learn how a steam turbine plant works. This program helps you to understand the turbine plant and then use your acquired knowledge to safely operate steam turbine-powered ships. A steam turbine plant comprises various devices and equipment assembled into a closely interrelated whole. This means that any malfunction of one particular device or equipment will affect the plant's overall performance. Let's take a look at the plant outline by following the flow of steam. Heated by fuel oil combustion gas, boiler water becomes saturated steam in the steam drum. With additional heating, this steam becomes superheated steam. Some of the superheated steam is sent to the desuperheater in the steam drum and cooled down. This steam is called desuperheated steam. Superheated steam enters the main engine turbine and expands, rotating the high and low pressure turbines at high speed. This turbine rotation produces rotational force for the propeller via the reduction gear. The steam that has expanded in the low-pressure turbine until its pressure is almost lost is then guided into the main condenser as exhaust steam. Having entered the main condenser, the exhaust steam is turned into water by cooling seawater. This water is called condensate water. The condensate water is pumped out by the main condensate pump. It's then sent to the boiler steam drum as feed water after being deaerated and heated, where it turns into steam again to complete the steam cycle. Since the steam cycle is not open to the atmosphere throughout its process, it's also called a closed cycle. The steam cycle consists of the main steam system, condensate water system, and feed water system. To operate this steam cycle efficiently, the desuperheated steam, steam bleed system, drain system, and feed water makeup system are provided. Saturated steam generated in the steam drum is heated again in the superheater to become superheated steam with higher heat energy, with its temperature raised but its pressure remaining unchanged. Superheated steam powers the main engine turbine and main turbo generator. It's often referred to as main steam, since it accounts for approximately 90% of the total amount of steam generated in the boiler. Some of the superheated steam is sent to the desuperheater in the steam drum, and its temperature is reduced. Called desuperheated steam, this steam is used to drive the main feed water pump and to heat feed water and so forth. When the main engine maneuvering lever is operated in the ahead side, main steam passes through the maneuvering valves ahead side. and is sent into the high-pressure turbine via nozzle valves. Steam used to rotate the high-pressure turbine also turns the low-pressure turbine, before being returned to condensate water in the main condenser. The amount of steam that enters the high-pressure turbine is regulated by the opening of the maneuvering valve and the number of nozzles used. These methods are known as throttle governing and nozzle governing, respectively. This combined governing method is unique to steam turbines. When the main engine maneuvering lever is operated in the astern side, main steam passes through the maneuvering valve's astern side and is guided into the astern turbine, coaxially arranged with the low-pressure turbine. It then reverses the turbine rotors. Main steam also drives the main turbogenerator. The steam, after driving the generator, is guided into the auxiliary condenser to become condensate water. Two flows of condensate water from the main and auxiliary condensers meet and are returned to the main boiler. Exhaust steam from the low-pressure turbine returns to water after being cooled in the main condenser, suspended from the bottom of the low-pressure turbine casing. This water, known as condensate water, is collected in the hot well located at the bottom of the main condenser. A vacuum pump enhances steam performance and achieves efficient condensation, maintaining a high vacuum inside the main condenser. Condensate water collected in the hot well is sucked in by the main condensate pump. It's mixed with condensate water from the auxiliary condenser and then passed through the gland condenser and first stage feed heater before being sent to the deaerating feed water heater. Leak-off steam from gland sections of the main engine turbine and other units is called gland exhaust. Together with air extracted from the deaerator, the gland exhaust is guided into the gland condenser and used to heat condensate water, while also being transformed back into water and collected in the drain collecting tank. The first stage feed heater uses third bleeder steam from the low-pressure turbine as its heat source. Bleeder steam used to heat condensate water in the first stage feed heater becomes drain and is brought into the main condenser hot well. The drain level is kept constant by a level control valve to maintain the pressure inside the heater. It's very important to keep the level of the main condenser constant to maintain operational stability of the turbine plant. To keep the level constant, therefore, the condensate recirculating valve is used to return to the main condenser some of the condensate water that has left the gland condenser. The deaerating feed water heater removes dissolved oxygen from the water and then reheats the water, serving as the second stage feed heater. This equipment consists of a deaerating chamber and a water storage tank. Condensate water is sprayed directly into the deaerating feed water heater through a nozzle attached to the upper part of the heater. The deaerating feed heater deaerates dissolved oxygen while heating the condensate water by using steam from the exhaust main pipe. Exhaust steam from the main feed water pump, driven by superheated steam, and second bleeder steam are collected in the exhaust main pipe and kept at a constant pressure. The steam serves as a heat source for the deaerating feed water heater. Deaerated heated condensate water and drain from the third stage feed heater are collected in the water storage tank of the deaerating feed water heater. The tank's level is automatically controlled within a prescribed range to regulate excess or shortage of water within the entire cycle. Water that has exited the storage tank is called feed water. It's sent by the main feed water pump. Via the third stage feed heater, feed water control valve, and economizer into the main boiler steam drum. The main feed water pump is a steam turbine-driven pump. Rotation of the pump is automatically controlled to keep the feed water pressure constant by a governor, even when the feed water flow changes. The third stage feed water heater heats highly pressurized feed water for supply to the boiler. When the ship is in port, desuperheated steam is used for heating, but when at sea, the first bleeder is used to increase thermal efficiency. The feed water control FWC valve controls the amount of feed water by detecting water level and steam flow to keep the steam drum water level constant. The economizer is one of the pieces of structural equipment of the boiler. It heats feed water by using combustion gas that came after heating the main bank. The steam cycle involves losses such as uncollected steam and drain, among others. Condenser and boiler water levels must be kept constant. Since such a loss appears as a drop in the deaerating feed water heater level, an appropriate amount of make-up feed water should be supplied as extra feed by detecting the drop. Provided for this purpose is the feed water make-up system from the distilled water tank. The feed water make-up valve opens as the deaerating feed water heater level drops, sending make-up feed water from the distilled water tank to the drain collecting tank. This raises the drain collecting tank level. This in turn opens the level control valve, sending the make-up feed water to the deaerating feed water heater. Depending on plant condition, the water storage tank level of the deaerating feed water heater may also rise. In such an event, the condensate water spill valve opens to allow some of the condensate water that has come out of the gland condenser to escape into the distilled water tank. Desuperheated steam is made from superheated steam, the temperature of which has been lowered by passing some of the superheated steam through the desuperheater. This steam is used for driving the main feed water pump, heating third stage feed heater, as backup for exhaust main pipe, as gland steam, for main engine turbine warming up, heating main boiler not in service, as burner assist steam, for soot blowing, and heating low pressure steam generator. Desuperheated steam that has completed its tasks becomes exhaust steam, condensate water and drain, and is collected in any one of the main condenser, auxiliary condenser, deaerating feed water heater, or drain collecting tank. The main boiler is composed of the steam drum, water drum, main bank, screen tubes, water wall, downcomer, riser, superheater, economizer, and furnace, where fuel oil is burned. The main boiler has the following attached equipment: combustion unit, gas air heater, forced draft fan, soot blower, and automatic combustion control equipment. Fuel oil is supplied from the fuel oil settling tank. Pressurized by the fuel oil burning pump and heated by the fuel oil heater. After passing through the fuel oil flow control valve and fuel oil emergency shutoff valve, it's then atomized from the burner. Two burners, a base burner and auto burner, are provided for each boiler. The base burner continually burns fuel oil, while the auto burner is automatically ignited or extinguished according to boiler load. Air required for combustion is force-fed by the forced draft fan. Heated by the gas air heater. Then enters the furnace to burn the fuel. The amount of air is controlled by detecting fuel oil pressure and flow. The high-temperature combustion gas that's been generated in the furnace, surrounded by the water wall, is exhausted after heating the screen tubes, superheater, main bank, economizer, and gas air heater. Boiler water in the water pipes connecting the steam drum to the water drum is heated by the combustion gas and then circulated. While circulating, some of the boiler water becomes saturated steam and is collected in the upper part of the steam drum. Saturated steam that has exited the steam drum goes into the superheater and becomes superheated steam. Some of the superheated steam is sent to the desuperheater in the steam drum, where its temperature is lowered to become what's called desuperheated steam. The amount of steam consumption varies according to factors such as main engine turbine and main turbo generator loads. However, the automatic combustion control and other equipment work to maintain constant superheated steam pressure and temperature and the drum level. Automatic combustion control, ACC, equipment, which detects steam pressure and fuel oil flow, maintains the superheated steam pressure at a setting value by controlling the opening of the fuel oil flow control valve and the forced draft fan inlet vane. Steam temperature control, STC, equipment, which detects steam temperature and airflow, maintains the superheated steam temperature at a setting value by controlling the opening of the STC valve. Feed water control, FWC, equipment, which detects the steam drum level and steam flow, maintains the steam drum water level at a setting value by controlling the FWC valve opening. Steam bleeding is carried out when the main engine load is greater than the prescribed value. The bled steam is used as a heat source for feed water and enhances the entire turbine plant's thermal efficiency. The first bleeding steam is extracted from the high-pressure turbine and used as a heat source for the third stage feed heater. The second bleeding steam is bled from the receiver pipe, connecting the high-pressure and low-pressure turbines. The bled steam is guided into the exhaust main pipe and used as a heat source for the deaerating feed water heater. The third bleeder extracts steam from the low-pressure turbine and uses it as a heat source for the first stage feed heater. Labyrinth packing is installed in the 4 gland sections, where the main engine turbine's rotors pass through the turbine casings, and air tightness can be maintained by providing the packing with gland steam. The gland steam receiver sits between the high-pressure turbine and low-pressure turbine. The steam receiver's pressure is maintained at a setting value by the gland steam makeup valve and gland steam spill valve. When the turbine is stopped or in low-load operation, the gland steam makeup valve opens to supply gland steam from the steam receiver to each of the gland sections. When the turbine is in high-load operation, since the turbine's internal pressure is high, the amount of leak-off steam from the interior of the gland section increases. In this case, excess steam flows backward to the gland steam receiver and passes into the main condenser via the gland steam spill valve. The gland leak-off steam receiver, installed between the high-pressure turbine and low-pressure turbine, collects leak-off steam from outside of the labyrinth packing. Leak-off steam is sucked in by the gland exhaust fan, sent to the gland condenser, and transformed into drain. Gland leak-off steam from the maneuvering and astern guardian valves is also collected in the gland leak-off steam receiver. During startup or low-load operation of the steam turbine, some of the operating steam is cooled in the turbine and becomes drain. Since drain can cause drain attack and damage the turbine, it's removed from the turbine casings, steam pipelines, and other sections and collected in the main condenser. The drain system comprises devices such as drain pockets to collect drain, orifices to limit the amount of steam leaked with the drain, valves to close drain lines, and drain traps to let drain pass but automatically prevent passage of steam. Lubricating oil, LO, is supplied to lubricate the main engine turbine bearings, reduction gear bearings, and reduction gear and flexible coupling tooth flanks, among others. Meanwhile, main engine control oil is used as hydraulic oil for the maneuvering system, safety devices, and for engaging, disengaging turning gear. Lubricating oil from the LO sump tank is supplied to the sections concerned after being pressurized by the main LO pump. Its temperature is maintained at a setting value by the temperature control valve at the main LO cooler outlet. Should the main LO pump stop due to a blackout, the LO gravity tank ensures lubricating oil supply for a certain period of time. The main LO pump feeds lubricating oil at all times, filling the gravity tank to overflow with lubricating oil. The overflow of lubricating oil can be confirmed visually by checking the sight glass. The main lubricating oil system has a bypass purifying line with a purifier that's used to continually purify lubricating oil when the main engine is in operation. The main circulating system is responsible for the supply of cooling seawater to the main condenser and main lubricating oil cooler when the main engine turbine is in operation. The main circulating pump is used to suck in cooling seawater from the sea chest, and the seawater is sent to the main condenser. Since the amount of cooling seawater directly affects vacuum inside the main condenser, it's regulated by the opening of an overboard valve. Abrupt inflow of high-temperature steam into a cold steam turbine generates dangerous drain that can damage the turbine. It also generates excessive heat stress that gives rise to irregular expansion of the turbine rotor and casing, which can lead to serious accidents, such as contact between rotating and stationary sections of the turbine. Therefore, the entire turbine must be sufficiently warmed up before being put into operation. Steam turbine warming up operation is largely divided into warming up preparation, warming up operation, and trial run preparation, which should be carried out in the steps shown here. Warming up preparation begins with the setting up of pertinent systems necessary to operate the main engine turbine and is carried out in the following steps. Ignite the boiler and raise its steam pressure. Conduct visual inspection and initiate power supply. Set up main lubricating oil system. Set up main circulating system. Set up main condensate water system. Test main engine control system. And start main engine turning. Then take the following steps to proceed with warming up procedures to warm up the turbine with steam. Supply gland steam. Start main vacuum pump. Supply warming up steam. And warm up main steam piping. Now the main engine turbine warming up begins. Finally, prepare for trial run by taking the following steps to bring the turbine from the state of warming up to operational condition. Put both main boilers into parallel operation. Stop warming up steam. Increase main condenser vacuum. Open main steam intermediate valve. And stop main engine turning. Upon completion of these steps, the turbine is now operable and starts spinning. Now let's look at the actual warming up operation. Start lubricating the oil purifier 12 hours before departure and heat lubricating oil in the sump tank. It's necessary to supply lubricating oil with appropriate viscosity to main engine turbine bearings, reduction gear, and so on. Since one of the two main boilers is laid up while in port, ignite it and raise its steam pressure before departure. Ignite boiler and raise pressure. Start pre-purge by starting a forced draft fan, FDF. Pre-purge refers to a procedure to purge flammable gas that might have been left in boiler furnace and replace it with fresh air. Insufficient pre-purge involves a risk of backfiring because flammable gas left in the furnace may explode when ignited. During pre-purge, slightly open the superheater vent valve to generate a steam flow within the superheater. This prevents burnout of the superheater. Upon completion of pre-purge, set fuel and air control output signals of the automatic combustion control, ACC, in the control room to those at the time of ignition. In front of the burner, fully shut the air register damper to prevent flame from being blown out at time of ignition. Reset fuel oil emergency shutoff valve and open fuel oil line valves and cocks. Insert igniter into ignition hole. Turn ignition switch on and depress foot switch. This opens the air-driven fuel oil piston valve and atomizes fuel oil. After ignition has been confirmed, fully open the air register damper to blow air into the furnace for combustion while observing the state of the flame. Then pull out the igniter. In the control room, adjust the ACC to conduct burning at the lowest oil pressure. Conduct steaming according to the benchmark of raising pressure by adjusting the opening of the superheater vent valve. Inspect, prepare and initiate power supply. Initiate power supply necessary for operation and warming up of the main engine turbine. Also, set dial gauge for the measurement of main engine expansion at 0 to monitor thermal expansion of the turbine casing being warmed up. Set up main lubricating oil system. The main lubricating oil system conducts warming up while supplying lubricating oil to bearings and reduction gear tooth flanks. Since it's necessary to fill the lubricating oil gravity tank, the main lubricating oil system must be set up at a relatively early stage by starting the main lubricating oil pump. fully open main lubricating oil pump suction and discharge valves and the pressure regulating valve to alleviate the power required to start the pump and protect it. Then start the pump. Regulate discharge pressure after the pump has been started. Set up main circulating system. As warming up begins, warming up steam and gland steam flow into the main condenser. To prepare for cooling such steam, set up the main circulating system in advance by starting the main circulating pump. First, open the C suction valve. Next, open the overboard valve to 20%. The overboard valve, which is controllable from the control room, is used to regulate the flow of main circulating water to the main condenser. Start the main circulating pump and check electric current value. Check pressure value. Confirm the state of running. Then open the pump discharge valve. Set up main condensate water system. As warming up begins, warming up steam and gland steam are condensed in the main condenser and the hot well level rises. Therefore, it's necessary to set up the main condensate water system in advance by starting the main condensate pump. After having opened all the pertinent valves, start the main condensate pump. While the main engine is running, the main condenser level is kept constant by the condensate recirculating valve. At the start of the pump, pressure inside the main condenser is the same as the atmosphere. The hot well level will drop if the pump discharge valve is opened. Therefore, the hot well level must be maintained by opening the condensate water valve's bypass valve while opening the discharge valve little by little. Test main engine controller. Manipulate changeover switches on the main engine console to conduct remote-controlled opening-closing tests on a stern guardian valve. Drain valves attached to the main engine. And first and second bleeder valves. Set up the maneuvering oil pressure. Manipulate the maneuvering lever in the control room. Then confirm that the maneuvering valve and remote control unit are in good working order. After the confirmation is over, trip the maneuvering oil pressure. The maneuvering equipment comprises the maneuvering valve, lever linkage, hydraulic servo, and cam assembly. It works by interacting with a remote control unit, automatic control unit, and safety devices. Start-stop of the main engine turbine, changeover between a head and a stern, and rotation speed control are all performed by the maneuvering equipment. Its mechanism does not allow the ahead side and the stern side to open at the same time. Maneuvering valve opening closing is carried out by a cam-driven device, moving the pilot valve first. Hydraulic oil that has passed through the pilot valve works on the servo piston to move the maneuvering valve rod up and down. Start main engine turning. To start the main engine turning, the turning gear is engaged via remote control from the control room. Main engine turning is carried out to rotate the rotors and uniformly warm up all pertinent sections prior to heating with steam. It also helps to supply lubricating oil to the reduction gear uniformly. If warming up steam is supplied without the main engine turning, it may cause irregular expansion in the turbine's structural elements and/or bending of the turbine rotor. Warming of the main engine turbine is accomplished by supplying warming up steam. For steam to pass, it's necessary to remove drain from the turbine casing and keep the pressure inside the main condenser lower than the atmosphere. The following steps are necessary to maintain vacuum that allows the passage of warming up steam. Supply gland steam. To create vacuum inside the main condenser, supply gland steam to seal the rotor sections passing through the turbine casings. Confirm that the gland exhaust fan works properly, then open gland exhaust line valves. Open gland steam line valves and operate the make-up valve and spill valve by adjusting the pressure controller. Then confirm that the pressure in the gland steam receiver is maintained at a setting value. Start main vacuum pump. Once gland steam has been supplied and air tightness of the main condenser has been secured, start the main vacuum pump. Then repeat pump starting and stopping intermittently to keep the pressure inside the main condenser lower than the atmosphere. Supply warming up steam. Supply warming up steam by opening the warming up steam stop valve and a head and a stern warming up valves. Time required for warming up is usually at least 1 hour. Judgment of whether warming up has been completed or not is made by the difference in temperatures between inner and outer surfaces of the high-pressure turbine casing, the temperature of the exhaust space of the low-pressure turbine, and by determining the expansion of the low-pressure and high-pressure turbine casings by means of respective dial gauges. Warm up main steam pipe. Pipe warming up refers to the operation to warm up the main steam pipe leading to the main engine that's in a cold condition while in port, and to lessen thermal stress and prevent drain from accumulating in the piping. The higher the temperature and pressure and the larger the pipe diameter, the greater the significance is to piping warm up. When it comes to the main steam system, piping warming up is carried out by flowing superheated steam backwards through the main steam piping of the layup boiler. For the desuperheated steam system, piping warming up is performed by flowing steam backwards to the desuperheated steam stop valve of the layup boiler. Trial run preparation is conducted in this manner to get the main engine turbine operable, after warming up the main engine turbine and the main steam piping. Boiler parallel operation. Put both main boilers into parallel operation prior to trial run preparation. This operation is aimed at shifting from one boiler to two boiler operation mode by having the steam supply line shared by the pressure-raised layup boiler and the main boiler in operation. Key points of the procedures are as follows. With operation to put both main boilers into parallel operation, the layup boiler water level, which has shown virtually no change, begins to drop as steam is supplied. Therefore, it's necessary to set up a feed water line in advance by opening the feed water control valve's inlet-outlet valves. As the pressure of the layup boiler approaches that of the boiler in operation, replace its burner with a navigational burner. To replace the burners, first ignite the auto burner manually, replace the base burner while maintaining the flame, ignite the base burner, then extinguish the auto burner. To replace base burners, disable the flame eye first and close the fuel oil inlet valve to extinguish the flame. Then open-close the purge steam valve to purge fuel oil remaining in the burner. After fuel oil purging, close the steam assist valve securely. Then loosen the burner attaching bolt. Carefully pull out the burner after confirming that there is no blowing off of fuel and steam under this condition. Next, insert the navigational base burner. Open pertinent valves, then ignite the burner. Once the burner has been ignited, confirm the flame stability, resume the flame eye, then extinguish the auto burner. These steps complete burner replacement procedures. Once steam pressure of the layup boiler's superheater outlet has become almost equal to that of the boiler in operation, begin supplying steam by opening the main stop valve. Desuperheated steam stop valve and main turbo generator stop valve. Close the superheater outlet vent valve after confirming the steam flow. Stop warming up steam. Stop the supply of warming up steam by closing the desuperheated steam stop valve and warming up valve. Increase main condenser vacuum. Although the vacuum of the main condenser was maintained at a low level during warming up, now start continuous running of the main vacuum pump and increase the vacuum of the main condenser. Open main steam intermediate valve. Once vacuum of the main condenser has risen sufficiently, open the main steam intermediate valve and send in steam as far as the maneuvering valve. Stop main engine turning. Stop main engine turning by remote control from the control room and disengage the turning gear. Start main engine spinning. Start spinning immediately after main engine turning has stopped. Upon stop of main engine turning, proceed to spinning as quickly as possible so as not to leave the turbine stationary under hot conditions. Once the spinning has begun, use a listening rod to confirm that there is no abnormal sound inside the turbine casings and reduction gear casing. Trial run. Main engine trial run from the control room console is carried out in two modes, the lever control mode and the direct switch control mode. Lever control mode is a method to manipulate the maneuvering valve electrically and hydraulically via remote control. Direct switch control mode uses switches for direct control on the control room console to directly open, close the maneuvering valve electrically and hydraulically in the event the lever control mode control circuit has failed. Another is the emergency manual maneuvering handle method at the local main engine control stand. This method allows the maneuvering valve to be directly opened or closed by a manual handle to operate a linkage when the valve cannot be opened or closed hydraulically. As explained so far, a steam turbine-powered ship becomes ready for sailing after warming up preparation, warming up operation, trial run preparation, and trial run, all unique to turbine ships. We would like each one of you to make the most of this program to fully understand the turbine plant and to use your acquired knowledge for the safe operation of your steam turbine ship.